In a function, we have a set of x's that is related one-to-one to a set of y's. In an inverse function, we have a set of y's that relates one-to-one to a set of x's. So in a function, we get a y from a function of x. We put in an x value and we get a y value. In an inverse function, we put in a y value and we get an x value. Let me rewrite that and put the inverse notation. This little -1, that is the symbol for an inverse. So we put in a y value and we get back our x value. So essentially what an inverse function does is that it undoes what a function does. If I put in, let's say I put in f of 2, and suppose that my y corresponding to 2, so suppose I had a point 2, 5. If I put in, for my function, the value of 2, my y is going to be equal to 5. If I put in, for the inverse function, 5, I'm going to get 2. So what I'm doing is I'm taking my y value and then I'm solving for the x value. So I'm doing the opposite. Instead of having an x and solving for a y, we have a y and we're solving for an x. So essentially, like I said earlier, what the inverse function does is it undoes what a regular function does. A regular function does something, the inverse function undoes that. So let's talk about inverse relations a little bit more. So as we said, functions are one-to-one there. It's every x to one y. Every x must have only one y. In an inverse relation, it's going to be every y. In order for the inverse function to be, or the inverse relation to be a function, it also must be one-to-one. So let me show you what I mean. So we have x's and y's. Let's say we have x1, x2, x3, x4, y1, y2, y3, y4. We'll say this x corresponds to that y, x2 corresponds to y2, x3 to y3, and x4 to y4. If we were talking about a function, is this relationship a function? We have, remember, in order for a relationship to be a function, each x can only have one y. It doesn't matter if the y value is the same, as long as there's only one y. So this x has one y, this is one-to-one, this is one-to-one, this is one-to-one, one x, one y, one x, one y. So this is a function. But is the inverse relationship a function? So in order for the inverse relationship to be a function, each y can only have one x. Each y can only have one x. So we're reading it this way. And we can see that we have one y, one x, one y, one x, one y, one x, one y, one x. So this inverse relationship is also a function. So let's look at a couple other examples where we might get some different answers. Alright, so let's suppose x1 corresponds to y1, x2 to y2, x3 to y2, and x4 to y4. So let's figure out if the x to y is a function. So let's see if this is a normal function. So we have x1 corresponding to y1, so this is one-to-one, x2 to y2, that's one-to-one, x3 to y2, that's one-to-one. Even though these are the same, that's fine, because each x only has one y, and x4 to y4. So this is a function. Now let's find out if the inverse is a function. So we have, and remember, in order for the inverse to be a function, each y can only correspond to one x, because it's as if our x's It's as if our y's are now x's. That's essentially what we've done. We've replaced x with y and y with x. So this must be 1 to 1 going this way in order for the inverse to be a function. So y1 to x1, that's 1 to 1, 1y, 1x, that's fine. But here we have y2 corresponding to x2 and x3. So this is not a function. So this is not a function because we have a y with two x's. It would be as if we had an x with two y's going for our regular function. So this is not going to work. This is not 1 to 1. So not 1 to 1. So the inverse of this is not a function. And I have one more that I want to look at. So let's say we had same thing, x1, x2, x3, x4, x5, and we had y1. And this one I'm going to add, actually no, I don't want x5. Let's just add y5. So let's say that x1 goes to y1, x2 goes here, x3 goes here, x3 goes here, and y4 goes here. And I want to know if this relationship of x to y is a function. We have x1, y1, this is 1 to 1, this is 1 to 1. This is not 1 to 1. We have an x that goes to y3 and y4. So this is not a function. But is the inverse a function? Well, let's go through the y. We have 1 to 1, 1 to 1, y3 goes to x3, so that's 1 to 1, y4 goes to x3, so that's 1 to 1, and y5 goes to x4. So this is 1 to 1. So the inverse of this is a function, while the original x to y relationship is not a function. The inverse of that relationship would be a function. And there's one more thing that I want to look at very quickly before we actually find what the inverse of a function is, the algebraic way. Let's talk about the vertical line test. Testing for functions. So if we recall, graphically, in order for something to be a function, it must pass the vertical line test. So say if I have some function like this, and I want to know if it's a function or not. Well, what I do is that I draw a series of vertical lines, and if it crosses more than once, then it's not a function. But you can see that here this is a function. So let's pick something that is not a function. So here's something again that's not a function. Because if we do a vertical line test, it crosses 1, 2 times. So this is not a function. However, in order to test for the inverse, if something is a function or not, we do the, alright, so if, for f of x, we do the vertical line test. If we want to know if the inverse of x is a function, then we do the horizontal line test. And this makes sense because if we're looking at it from a relationship of y to x, that means each y can only have one x. So if we do a horizontal line test, let's say here, we're going to see that y, if we have one y here, it has 1, 2, 3, 4 values for one y, 4 x values for each y. So this is not going to be an inverse function. But if we look at this example over here, we can see that no matter where we put a line on this graph, it's only going to touch it one time. And this would be an example where the inverse function would be a function, and the original one is not a function. But we can have graphs that have both being a function. Let's say we had, let me get my graphing tool. Okay. So let's say we had like x cubed or something like that. So x cubed looks like this. We can see using the vertical line test anywhere that this would be a function of x to y. It would be 1 to 1. And if we did the horizontal line test, we could also see that it's a function, because it would only cross one time going horizontally. So that's a quick test to see on a graph if something is a function and an inverse function. But now let's figure out how to find the equation of an inverse function. So let's say I have the equation y is equal to 2x plus 3, and I want to know what the inverse, let's write it in function notation first, I guess. So f of x, so we don't get confused, is equal to 2x plus 3. And I want to know what the inverse of x is. So as we discussed earlier, to find the inverse of a function is when we have a relationship x to y. And an inverse relationship is when we have y to x. So in order to find the inverse of this function, I'm going to replace y with x and then solve for it. So f inverse is going to be equal to, well, it's easier to write it in terms of y when we're going to be solving it. So this equation is, let's write it up here. This equation is y is equal to 2x plus 3. And this is when we're doing a relation x to y. So the inverse of that is going to be yx. So what we're going to do is we're going to switch. X is equal to 2y plus 3. And then I'm going to solve this for y. So x minus 3 is equal to 2y, and I divide by 2. Y is equal to x minus 3 over 2. That's a little bit crooked, but... So let's look at our function. So we had y is equal to 2x plus 3. Or let's write this in function notation now. F of x is equal to 2x plus 3. It doesn't really matter what notation you're doing, and I just find it easier to not get mixed up with the equation. So f inverse of x is equal to x minus 3 over 2. So if I put in an x for this equation and I find a y, this equation is going to give me, if I have a y, it'll give me the x. So let's solve for f of 2. So we get 2 times 2 plus 3, this is equal to 7. And as we said, this is the inverse relationship. This is y of x. So I have a y, I put it into the equation, and then I get an x. So theoretically, if I put in 7, I should get the original x too. So let's do that. So f inverse of 7 is equal to 7 minus 3 over 2. 7 minus 3, that's 4. So this is equal to 4 over 2, which is equal to 2. And we can see that this 2 is what I originally put in the equation over here. So as I said before, an inverse function is something that just undoes our original function. And we can prove that. Watch this. So if we have our equations, let's write them out again. F of x is equal to 2x plus 3, and f inverse of x is equal to x minus 3 over 2. If I did a composite function, let's say I did f of f inverse of x, what should happen? What should I get? Because f is the opposite of this. So what I should get is my x value back. So as we were saying, if this function gives me my y value, and then I put that y value in here, it should give me back my x value. So if I take f of x, and then I take the inverse of f of x, I should just get back my x value. So let's do a composite function and see what happens. So f of x is 2x plus 3. So what I'm going to do is I'm going to, inside of f inverse, I'm going to put in 2x plus 3. And this is going to be equal to 2x plus 3 minus 3 over 2. So 2x plus 3 minus 3, that's 2x. So this is going to be equal to 2x over 2. And then all I'm left with is x. So as you can see, it's true that if we put in, and if we did it the other way, we would get the same thing as well. So if we did f of inverse of x first, and then we did f of x, we should get back our same value. So anyways, this is just to show that the inverse function undoes what a function does. That's the way I think of it. It's just a tool to undo. It just undoes a function.